name is Bethany Bear. This is Diego Zapata. We're research student mentors here at AACC, and we're going over what's called a Thoughtful Thursday. The goal of the Thoughtful Thursday is just sort of like put a match on your brain, make you think outside the box. If we need to create an experiment, we can kind of just pass ideas back and forth. We take it to our mentor, Dr. Fox Moon, who can then say, hey, this is a good idea, you guys need to work on this. Our topic for today is artificial fields. And the only thing that I Googled was the layers to an artificial field, which is here on the board.
This is the individual nylon fibers with that backing. As you see, it's pretty tight. Water's not really going to go through there.
Okay, so let's think about what are some things we can look at for experiments. So we have UV. What happens when UV hits it?
Oh, let's go even broader.
Okay.
Let's go even broader. Students hopefully have taken some of these classes, and we can now start building off into this. If we're looking at microbiology, bacteria, exactly. Number one, Graham Stang, you look at different microbes and such. What about the microbes that are living on this artificial field? Ecology, Bethany's already in work mode, just going, firing. Exactly, we want to see how it affects the ecology, environment, right? Insects, biodiversity of plants. How do these, whether they be chemical or physical plastic particles, infiltrate? It may increase biodiversity. We don't know, right? Chemistry, as we know, hopefully with plastic degradation, it degrades in certain conditions. UV light is the big culprit. So if it's sitting in a bunch of sunshine because there's no trees on that entire field all day, every day for years and years and years, it's gonna start degrading. Heat islands.
Heat islands.
Heat islands. If you don't know heat islands, there's heat in a centralized area, parking lots.
I haven't taken physics yet.
Yeah.
What happens when we put these layers onto the natural soil to the grubs that live under there? The grubs, the worms.
Way down here?
Insects, yeah, in the natural soil. What happens?
That's interesting.
You can go a different route. Just pass back.
Yeah. My main thing with artificial fields, when I think environment ecology, is what is it doing to the surrounding environment, right? So underneath the field for sure, but you could take it from an epidemiology standpoint. Do people who live near natural fields, are they had a higher risk for cancer, right? You can look at, like I said, biodiversity. You have black-eyed Susans and all these healthy pollinators for insects and bees. And you could look at a natural field, right? And you can look at an artificial field and see where the biodiversity difference is, and you'd have to do a lot of surveys, a lot of artificial fields.
How does UV light hitting that field in the middle of a heat wave, since we're in the middle of a heat wave right now, how does that affect any animals that may pass through that field? Yeah?
Maybe. How would we do that? Would we set up a camera to look at animals?
We can set up a camera. We could also test how hot that field gets.
What would the control be? Because animals are very unpredictable.
Right.
Not sure about the whole animal thing just because we don't have like a way to control that. I would like to look at plants because plants don't move.
Okay.
I'm not a huge plant expert, but my understanding is they create a box, a 1 meter by 1 meter box, and they count the species that are in this box, and they can now create a biodiversity chart of how many species, how many are native, how many are invasive.
That goes back to the natural soil.
Kind of also back to the health. But as you get away from artificial field, at what point does it get back to the control? The control being a normal field.
Maybe how does the turf and all of these layers affect the natural soil, which in turn affects those natural plants and insects?
Yeah.
Right? So we could do, especially if we had two fields very close to each other, like, and then we go to one side, test, and go to the other side and test.
Yeah, I like it. Those factors we're controlling it for.
So light,
Light's a big one.
temperature,
For sure.
pH,
pH, water,
water.
amount of water. The amount of soil or artificial field should be similar. The other thing is just time, right? How long are we doing this for? We have our factors, but what are we specifically testing?
This is what I'm thinking. 2 artificial fields, one set to 180, so high end,
Yeah.
versus 140 degrees.
Well, we're looking at mainly, what are we looking at? How does temperature do what? Break down the plastic?
Right. We can look at how it breaks down, releases the microbe. We focus on emissions release and we measure how much gas or particulate matter that's being released. Then, once that experiment is completed, that can lead to a future experiment on how that particular matter or the gas affects human lungs. Design and experiment.
First thing first, we need a dome
Hmm.
or a box, right? Some are plastic field, which is gonna have a blue base. Give a
Little bit of grass.
little bit of
Or
grass.
turf.
He's also gonna have rubber crumb fill.
Mhm.
Last dome, we'll say a cubic foot of turf. We can
Silica gel packs for condensation control.
Yeah. We would have like a UV light over the top, right? Control the height of that, how far it is away. We would have a thermometer, glass thermometer inside, so we could see exactly what the temperature is in. We could have a heating pad underneath.
Mhm.
One heating pad at 70 degrees, one heating pad at 180 degrees. What would control be over here?
Just a dome with no added heat. The only thing that goes into the NC is the thermometer and the emissions, what is that thing called?
Draw a thermometer. The hole, we put a cork, a little wine cork in there, seal it up.
So it's a little probe thingy to it. Is it metal?
Take
Yeah,
the
it's
wine
metal.
cork out, suck out the air.
They have a metal probe in there.
Plastic under a microscope or dissection scope.
Right.
And you can see, is this one cracking? Is the nylon fiber unraveling around it? Meant to withstand heat. They're not meant to withstand UV and heat
Right.
and water. And that's why it's all
So
right.
just looking at the time, because as you guys can
Uh-huh.
see, this can take a long time. I think we're right at 45 minutes. We could go for hours. We could troubleshoot and things like that. I'm going to say put a pin in it. My question to you guys now is, did you think of anything the entire time we were up here where you went, oh, you guys could try that maybe we didn't come up with?
Yes.
Okay, share.
I was just thinking of like what types of domes we could have, but I guess glass would be the best. My
Yeah,
question
because-
is why though? Because metal also controls temperature, right?
Yeah, but if it's metal, we can't see through the dome.
And it'd be hard to get the UV, like, I mean,
Yeah.
I'm sure it would,
You can't
probably
get the
figure
light
out a way
source
to make
into
that
it.
work, but-
Yeah.
but I feel like it would be harder to figure out a way to make that work, cause it's opaque.
Okay, these little light bulbs, those are gonna be the UV lights.
Yes.
Yeah.
Wouldn't that? My question is like, how would that not affect the temperature for the room temperature? Wouldn't that make it warmer? Because UV lights are known to do that.
Well,
so I don't
that's
understand.
what Dr. Fox Moon said is we would have to set the light so then it was the same as everything else, but we would have to make sure we're controlling that temperature. So maybe light exposure just so you can see it, but then you'd have to control the temperature of the light itself. So maybe we look for a specific bulb that doesn't,
Heating pads.
yeah.
Heating pads is how you change the temperature. Heat it from the bottom up.
Is the thermometer for the inside of the dome or for
Yes.
the turf?
It's for the inside of the dome to measure the temperature inside.
To me, I would say that makes sense because then you'd be trying to reach like the desired temperature of the surroundings, and then in theory, maybe for the one with the turf in it, you'd wanna have an additional temperature.
That's what I was gonna say, is that maybe having a
At the
second thermometer
difference.
in the turf
Yeah.
to help confirm that it is
Okay.
the correct
Like that
temperature.
it's actually.
Because even these layers, I drew the
Yeah.
layers, but some of these are optional. So it depends on how much you wanna spend on
Well,
your
exactly.
turf.
The black
So-
rubber is gonna absorb heat way more